All right, so this video is going to talk about standard deviation. So far, if I'm being honest with you, everything that we have done statistically has been very elementary statistics. We are now reaching the point where this is college statistics right now. I'm going to play this video and kind of talk over it, and then I will show you how to do this, and then should really be it for today. So here we go.
Have we discovered a new particle in physics?
Who knows?
Is a manufacturing process out of control?
Out of control.
What percentage of men are taller than LeBron James? How about taller than Yao Ming? All of these questions can be answered using the concept of standard deviation. For any set of data, the mean and standard deviation can be calculated. For example, 5 people may have the following amounts of money in their wallets: $21, $50, $62, $85, and $90. The mean is $61.60, and the standard deviation is $28.01.
So we know how to figure out what the average is, or the mean, and now we're learning a new word called the standard deviation. And what they're telling us is that the standard deviation is $28.01.
How much does the data vary from the average? Standard deviation is a measure of spread, that is, how spread out a set of data is. A low standard deviation tells us that the data is closely clustered around the mean, or average, while a high standard deviation indicates that the data is dispersed over a wider range of values. Standard deviation is used when the distribution of data is approximately normal, resembling a bell curve.
So we cannot use the standard deviation on skewed data.
Standard deviation is commonly used to understand whether a specific data point is standard and expected, or unusual and unexpected. Standard deviation is represented by the lowercase Greek letter sigma.
We'll talk about that.
A data point's distance from the mean can be measured by the number of standard deviations that it is above or below the mean. A data point that is beyond a certain number of standard deviations from the mean represents an outcome that is significantly above or below the average. This can be used to determine whether a result is statistically significant or part of expected variation, such as whether a bottle with an extra ounce of soda is to be expected or warrants further investigation into the production line. The 68, 95, 99.7 rule tells us that about 68% of the data fall within one standard deviation of the mean.
We're going to talk about this way more in detail. He's kind of giving us like a spoiler alert of when you use the standard deviation. Let him finish doing this and then I'll jump in.
About 95% of data fall within 2 standard deviations of the mean, and about 99.7% of data fall within 3 standard deviations of the mean. The average height of an American adult male is 5'10", with a standard deviation of 3 inches. Using the 68, 95, 99.7 rule.
So let's not talk about the percentages. Let's just talk about this. The average height is 5'10". Somehow they did a calculation and got a standard deviation. I don't know what numbers they used, but they used numbers.
This means that 68% of American men are 5'10", plus or minus 3 inches.
So all you're doing, the standard deviation is how far away it is from the mean. So if 5'10" is the average, on either side, here you added 3, here you subtracted 3. Another standard deviation away would be
95% of American men are 5'10", plus or minus 6
and
inches.
Subtracting 3 more.
99.7% of American men are 5'10", plus or minus 9 inches.
Taking away 3 more.
So this means only about 0.3% of American men deviate more than 9 inches from the average, with 0.15% taller than 6'7", and 0.15%
we will talk about all these percentages next week.
This reasoning suggests that LeBron James is 1 in 2,500 and Yao Ming is 1 in 450 million.
So I'm going to stop it here. Just to go back to this question about the money in people's wallets. When they found the standard deviation, it was 28.01. So what that's telling you is that if you were drawing a graph where the average is 61.6, the standard deviation is kind of like how you set up a bell curve. So if the standard deviation is $28? $28.01. So in order to get these like boundaries, you would add 2801 and you would subtract 2801. So this would be 8961. And this would be 3359. And then you just keep on adding and subtracting your standard deviation. So it's just a way for you to set up the bell curve. We are going to talk about the bell curve. That's this entire chapter. If you look over here, that's what we are working towards. Standard deviation, bell curve, and something called z-scores. The z-scores involve a very large chart full of data. And hold on. Here we go. All right, so let's talk about the standard deviation. A lot of new words here and a lot of symbols. This looks like a very confusing formula. I do want to just talk about how to do this by hand, but we are going to do it using either a calculator or a website. If you have a TI 84 or 87, I think, you can do this on your calculator. If you don't, I'm going to give you a website that we can do it on. But I just want to look at it so that way, like, we're understanding what it's talking about, what all these symbols mean. Okay? So let's first talk about the big E. Okay? This big E is called a sigma. It is a Greek letter. And that is the capital version of a sigma. Okay? Sigma just means the sum. So if I said, hey, here's some numbers, 1, 2, 3, 4. What's the summation of the numbers? It would just be 1 plus 2 plus 3 plus 4, and that would be the answer. So anytime you see that, it just means add up everything that it's talking about. This is a lowercase sigma. You're kind of writing it like, I kind of write it like a crooked 6. And this is the formula for standard deviation. So again, we are going to learn how to do the formula by hand. It's not very difficult. It's just time consuming, and it's 2020. It's almost 2021. So really we shouldn't be doing it by hand, but I just would like to show you, us teachers, to show you first how to do it by hand and then make it easier. Okay? Remember, anything X bar, remember we said denotes the mean. Just like we said, X tilde is the median. We don't need that here. Just a quick refresher. X is just a number. N is the number of values in the set. So let's just talk about this first. What, do we have data here? We don't have data. All right, so let's make up some numbers here. Let's say we took a survey, and the survey was, how many people are coming back hybrid in each of my classes? If you want the real numbers, I can tell you them. I'll just make them up because I kind of know what they are. So total number of hybrid students coming back to school. I don't know what the numbers are exactly, but it's probably something close to like 6, 5, 7, 4, and I think you guys have a lot of people coming back. I think it's like 12, maybe 13. Let's go with 12, okay? So this is going to tell you what is going to be the standard deviation of about how many people are going to be in each of your classes when you return next week. So the first thing we're going to do is first figure out what the average is. And the average is going to be the same for all of the data. So first, let's find out what the average is. So step 1, calculate the mean. Remember, we're doing this by doing 6 plus 5 plus 7, that's 18, plus another 16, so that's 40. And this works out nice because 40 divided by 5 is 8. So it means the average number of people coming to school in my class for like period 1 would be 8 people. And then, of course, split up by 2. So I can expect that I'd have about 4 students in each class. Now, I know that's not true because I think in the first half of the alphabet, there's about 9 of you coming back. on one day. But anyway, that's the average. Some classes I have one student that will be sitting with me. Sometimes I'll have two. But on average, 8 is about how many people will be in each class. Now, this is going to be, just setting it up, what is this number minus the average? So 6 minus 8, negative 2. 5 minus 8, negative 3, negative 1, negative 4, and positive 4. Now, the standard deviation says it wants us to take the summation of the differences that we just found and then square them. So let's do that. What is the summation? Whoops. First, I'm sorry, let's subtract first. Let's square them first. So first we're going to square all of these numbers. So this little table is like setting it up for us. All of these numbers squared would be positive 4, positive 9, positive 1, positive 16, and positive 16. So now that is all of the tables, all of the numbers squared. Okay? So we did the average, we took it away from the number, and then we squared it. Now I'm going to find the summation of all of these numbers, which essentially just means add. Add all of these numbers together. That would be 13 plus 1, that's 14, plus 2 16s, that's 32, so it would be 46. So just the denominator is going to be 46. And then this term on the bottom says to take the number of terms minus 1. So the number of terms here is 1, 2, 3, 4, 5. Minus 1 is 4. And then I'm going to divide this. It's 46 divided by 4. This is where we're going to start to get some very crazy decimals. In this case, it's not that crazy, but we are going to get very odd decimals. At this point, things are not just going to be nice numbers. Okay? This that we just calculated is called the variance. And in order to find the standard deviation, or lowercase sigma, all you do is take the square root of the variance. So I'm going to take, let me do that here. The square root of 11.5 is 3.39. Now, obviously, I know that we cannot have partial students in this class. That's okay for right now. We're going to just leave it alone. What this tells me is that if I was going to make this curve, and let's not even talk about the percentages, if I was going to make this to start to set up my graph, the average goes in the middle. Remember, the average of the data was 8. And the standard deviation tells me what the rest of my numbers should be here. So the next one would be 8 plus 3.39. 11.39. You would add another one. 11.78. No, 14.78. And then lastly, 18.17. We only go up to 3 standard deviations. After that, because remember I was talking about that 95, 99. 99% of the data is contained in what we're talking about. So there's really no need, like that 1% doesn't truly matter. This is going to be 4.61, 1.22. Obviously, I know I cannot have negative students, but if I were making this graph, technically there would be a negative over there just to make it symmetrical. Okay? All right, so I'm just going to practice again. First thing I do, find the average of the data. I'm not going to answer this question. Okay, first I'm going to find the average of the data. So let's add up all these numbers. 13.4 plus 11.7 plus 18.3 plus 14.8 plus 14.3 divided by, you should have gotten 72.5. Divided by 5 is an average of 14.5. So no matter what column you're in or what row you are in, the average of the data does not change. Okay? Now you're going to find the difference between the numbers. Negative 1.1. I feel like I'm the only person who can never type on the iPhone calculator. Like, it always takes me 12 minutes to do one question. I don't know if that's just me. Would this be 0.3 and negative 0.2? Okay, then I'm going to square all of these numbers. Okay, then I add them all together. I get 23.62. My dogs are going to bark now. Remember, that's the variance. And then to find the standard deviation, you just take the square root of this. So the standard deviation is 4.86. And that's all we're doing. Okay. So I'm going to leave. We don't need to do this however many times. Let's just do these two. I'm going to leave you these two charts. Maybe I'll just put this in a Google form. I'll do that. I'll put this in a Google form. Or you know what? How do I want to do this? I don't know. I'm just talking to myself. I'm going to put this somewhere. I'll put this somewhere and you can fill in the answers. Maybe I'll make it on a spreadsheet. And then you're going to answer which one has a greater standard deviation.